In this video, we'll talk about finding the volumes of solid revolution when the revolution axis is not just the x-axis. So it's possible to also find these volumes if you have a horizontal line you want to rotate around that isn't the x-axis. It could be the line, say, y equals 10, y equals minus 5, any other horizontal line. It's possible to figure out the volumes of these solids revolution as well. You just be a little more careful with how you set it up. So, for example, say I have a region between two curves like before, something like this. If I want to revolve that around the x-axis, that is good, that's fine. I would have this bit here as my inner radius, and this length here as my outer radius, i.e. this would be just f of x, and this would be just g of x, for what these different radii are for this function. Now, let's say instead I want to revolve it on the line y equals minus 2. Well, that's totally fine, I can also do that. I just have to figure out what my inner and outer radius are, because these two are not right anymore. So instead, now I have this length here as my inner radius, and this length here as my outer radius. What are those lengths? Well, for the inner radius, it's just g of x would get me to the axis. I need to go 2 further to get the actual line of rotation. So this should be here, g of x plus 2, and similarly this should be f of x plus 2. So in this case, to find the volume of the solid revolution around y equals minus 2, I would want to look at the volume, which was the integral from a to b. I'll have the pi still, the outer radius squared, which is no longer just f, it's now f of x plus 2 squared, minus the inner radius, which is g of x plus 2 squared. And that would give me the volume of that solid revolution as well. Now, as one more sort of example, what about the line y equals 10? And we'll assume that line's way up here on top. Well, now my radii are wrong again, so let's erase those again. Now with this line of rotation, what's my radius? Well, my inner radius now should go from the axis of rotation to the curve. So this here should be my inner radius, and this here should be my outer radius. Well, now how do I find these radii here? Well, the inner radius should be how far f is away from 10, so this would be here 10 minus f of x, and similarly the out should be 10 minus g of x. How far g is from 10, we know g is below 10. Also, these radii should both be positive numbers because we're looking at distances here. So 10 minus f is a positive number for that distance there, and 10 minus g is also positive. How do I find the volume in this case? Well, still pi integral from a to b, but now what's my outer radius? My outer is now 10 minus g of x squared minus the inner radius, which is 10 minus f of x squared. So you can get things that look a little bit different depending on what lines you're rotating around, but I always like it better to sort of step back and figure out what's my inner radius, what's my outer radius, how does it look based on the graph and where these lines are, and use that to figure out how to put this all together to get a solid picture for how to set up this equation. It's always going to be pi integral something squared minus something squared. It's just figuring out what goes into those somethings to fit with the picture you have for the problem you're dealing with. And now let's look at an example. Find the volume of the solid revolution obtained by revolving the region between y equals 1 minus x squared and y equals x squared minus 1 around the line y equals 3. So these are both parabolas, one's up, one's down. Let's draw a picture and see what they look like. They're both going to cross at 1, 0 and minus 1, 0. Something like that is your region. And the line you care about is y equals 3, which is going to be up here. So this graph here is 1 minus x squared. This graph here is x squared minus 1. And so now I want to figure out what's my inner radius and what's my outer radius. Well, my inner should be from the line to this first function, which is the 1 minus x squared parabola. My outer should be from the line down to here. So what's my formula then? My formula should be the volume is the integral from minus 1 to 1, because that's the region where this curve takes up, a pi, outer radius squared. So that's 3 minus x squared minus 1 squared, minus inner, 3 minus 1 minus x squared squared. And then we just want to simplify our expressions, expand things out, and solve for the integral here. That's what we get when you combine this stuff in the parentheses. Then let's FOIL everything out and see what we get. The x to the fourths are going to cancel, then we can just integrate and solve out from there. And so the volume comes out to 16 pi. You get 8 from each side, so you get 16 pi total. So that's the idea of solving these problems when the axis of rotation is not just the x-axis. If it's just the x-axis, you get a 0 and it's all good. But if it's not the x-axis, you want to look at the problem and figure out what are my radii based on where this axis of rotation is, and use that fact to set up the formula you need for the problem, and then solve it out directly with our same integral of pi outside squared minus inside squared dx formula like we had before.